Welcome to my science tutorial. In this video, I want us to look at Graham's law of diffusion. Graham's law of diffusion. So first of all, let's find out what diffusion is. Diffusion is the movement of gaseous particles. We're dealing with gases here, so gaseous particles into space until the molecules are evenly distributed. What does that mean? Now, we can also say that diffusion is the movement of particles from a region of higher concentration to a region of lower concentration, or we'll say over a concentration gradient. So what we have here is, let's say this is an aerosol, an air refresher, and we have these gas particles in here. So let's say these are the gas particles. If these are the gas particles, we have these gas particles locked in here. So when we spray, the particles will come out from here and start moving in all directions. Let's say this is a room. So when this is sprayed at one part of the room, within some few minutes, you begin to smell it at the other part. If this is point A and this is point B, we begin to smell it here. Why? Because the particles are moving from this region where they are highly concentrated until they are evenly distributed all around in the room. So that is diffusion. That's what diffusion is. Now, there's another term that we can look at. We have what is known as effusion. We have what is known as effusion with an E. Effusion. Now, what is effusion? Well, effusion is also just like diffusion. The only difference is when you have a container. So let's say this is a box. Let's say this is a box. And we have gas particles in there. We have gas particles in there. Now, when we have an opening here, a small opening here, where the gas particles move around randomly, kinetic theory of gases will say the gases are in constant motion and then they collide with each other in the walls of their container. So one way or the other, once there is an opening here, these gases will pass through this opening and begin to spread out. Now that process is what is known as effusion. That is what is known as effusion. Now, what does Graham say about diffusion? Now, Graham's law of diffusion states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. So how do we express that? What he's saying is the rate, which I'm going to call R. So rate R is going to be equal to, or let me not use equal to, let me use the proportionality sign. So you're saying that it is proportional, it is inversely proportional to the square root of its density. So let's bring out square root, and inversely proportional means 1 over the density, which we call d. So we have R for rate and the d for density. So when we introduce a constant of proportionality, we'll say that the rate R is equal to K and the square root of 1 over D, which is density, 1 over D. So usually we'll consider the ratio between diffusion of two gases. So when we consider two gases A and B, so considering two gases A and B, we'll be looking at the rate of their diffusion. So for the gas A, its rate of diffusion is going to be equal to the the rate constant, the diffusion rate constant, and then we'll have 1 over the density of A, and that of B, the rate of diffusion of B, will be equal to K, the square root of 1 over the density of the gas B. So when we find the ratio between these two, the ratio of A to B, we'll say that the rate at which A diffuses with respect to that of B will be equal to that of A, 1 over the density of A, all of this divided by the constant 1 over the density of B. So that's going to be the ratio between them. Now, when we cancel these guys out, the constant out, and then these are inverse and we are dividing. So at the end of the day, what we are going to have is, let me take a different color for this. What we are going to have is, we will have the ratio of diffusion of A to the ratio of diffusion of B to be equal to the square root of the density of B dB over the density of A. So notice it is being reversed because we are dividing here and these are fractions. Okay, so this is actually one of the equations for determining the ratio of diffusion between two gases. The ratio of diffusion between two gases. So again, let's look at this. We said from Graham's law, we can say that the rate of diffusion of A to the rate of diffusion of B is equal to the square root or the density of B over the density of A. This is one. We can also say that the rate of diffusion of A to the rate of diffusion of B is equal to the molar mass of B over the molar mass of A. This is another expression. Okay, and this actually makes sense. What it's simply saying is that the heavier the gas, the slower it moves, or the slower it diffuses, but the lighter it is, the faster it diffuses. So this is also another expression. Now we can also say that there is another expression that says that when we are considering the time of diffusion, we'll say the time of diffusion of A to that of B is going to be equal to the square root of molar mass of B over the molar mass of A, or the square root of the density of B over the density of A. Okay, so these are the equations or the expressions that you are going to be dealing with when it comes to questions around Graham's law of diffusion. So let's look at some questions. Now this question right here says that 280 cm cube of nitrogen gas diffused through a membrane in 70 seconds. How long will it take for 400 cm cube of carbon dioxide to diffuse through the same membrane? Now you can feel free and try the pause the video and try the question. Okay, so now we can decide to use this expression. We know this volume of nitrogen that has been diffusing, and then we know the time it takes. Okay, and then we know the volume of carbon dioxide, but we don't know the time it's taken to diffuse, and that is what we are trying to find. But before we continue, let's remember that the rate of diffusion is equal to the volume of the gas that is diffusing per time. Okay, so this may end up being like cm cube per seconds. or whatever unit of volume you use. Okay, so this is the question, and let's look at how we can solve it. Now, right away, we can pick the expression that the rate of diffusion of carbon dioxide, which is CO2, to the rate of diffusion of nitrogen gas will be equal to the square root of the molar mass of nitrogen gas divided by the molar mass of carbon dioxide gas. So this is simpler. So all we have to do is to find the molar mass of nitrogen gas and carbon dioxide gas. So let's do that. Nitrogen is 14. So nitrogen is nitrogen is 14. So 2 times 14 will give us 28. And then molar mass of carbon dioxide, CO2, carbon is 12 and oxygen is 16. So 2 times 16. And when we do that, we are going to have 44 grams per mole. 44 grams per mole. So these are the molar masses. Now we are trying to find the rate of diffusion of carbon dioxide gas. Now we know the volume of nitrogen, and we know the time, so we can find R N2, which is going to be equal to the volume, which is 280 cm cube divided by 70 seconds. And when we punch that, what do we have? We're going to have 4 cm cube 4 cm cube per seconds. So that means we'll have 4 cm cube of nitrogen gas coming out in every seconds. Okay, so let's put all these things back into the equation. So we have the rate of diffusion of carbon dioxide, CO2, and then over the rate of diffusion of N2, which is 4, and it's equal to the molar mass of nitrogen, which is 28, divided by the molar mass of carbon dioxide, which is 44. Okay, so this is the expression, and this is going to be equal to rate of diffusion of carbon dioxide over 4, and when we punch this, we have 0.8. 0.8. So this is going to be O2 equals 0.8 times 4, because when we multiply through here, times 4, this will cancel this. Okay, and when we multiply that, what do we have? We're going to have 3.2 cm cube per second. Sorry, 3.2 cm cube per second. So that's going to be the rate of diffusion of carbon dioxide. Okay, so now that we know the rate of diffusion, what we have to do now is to go ahead and find how long it will take for this 400 cm cube of carbon dioxide to diffuse completely. Okay, so the thing is, in every 1 seconds, we have 3.2 cm cube coming out. So how many seconds is it going to take x for us to have 400 cm cube coming out? So when we cross multiply, we're going to be having x to be equal to 400 divided by 3.2, and when we do that, we are going to have 125 seconds. 125 seconds. So this is one of the questions, and yeah, you can try more. Now let's look at our last question. Okay, so this is our last question. It says if 360 cm cube of hydrogen gas diffuse in 1 hour, how long will it take? How long will it take for 600 cm cube of a gas G whose vapor density whose vapor density which apparently is the vapor density is 25 25. Okay, to diffuse through the same membrane. That's what the question is. All right, so let's look at this. Again, we can use the same expression. We have hydrogen gas there, hydrogen gas, and we also have different gas, G, which we are calling G. Now, we can say that the rate of diffusion of the hydrogen gas to the rate of diffusion of the gas G will be equal to the square root of the molar mass of G divided by the molar mass of hydrogen gas. Okay, so this expression we are going to use. Now, with the hydrogen gas, we know that the mass of hydrogen is 1, so H2 molar mass of hydrogen gas is going to be 2 grams per mole. Now that of the gas G, now we don't know what gas it is, but we are given the vapor density, which is 25, and all we are going to do is, since we have the vapor density, 2 times the vapor density will give us the molar mass of that particular gas. So when we have 2 times 25, we are going to have 50 grams per mole. So that is the molar mass of the gas G. That's the molar mass of the gas G. Now, so what we are going to do now is to try to find the rate of diffusion of the hydrogen gas, because we have been given the volume and the time it has taken. So let's go on. The rate of diffusion of the hydrogen gas H2 is going to be 360 cm cube divided by 1 hour. We know that we have 60 seconds in 1 minute, and then we have 60 minutes in 1 hour. So this together will be in seconds. So when we punch that, what do we have? When we punch that, we're going to have 0.1 cm cube per second. Okay, 0.1 cm cube per second. Now, all we have to do is to put these informations back into the equation. So we are now going to have the rate or diffusion of hydrogen gas divided by the rate of diffusion of the gas G, which this time rate of diffusion of G. So this one is 0.1 over the rate of diffusion of G, which is equal to the square root of the molar mass of the gas G, which is 50, divided by that of hydrogen, which is 2. Okay, now this will go into this 25 times. So the square root of 25 is going to be 5. So 0.1 over the rate of diffusion of G is equal to 5. So when we multiply through by the rate of diffusion of G, this will cancel this. Then we have rate of diffusion of G. So when we make this the subject, we'll have R of G to be equal to 0.1 divided by 5. 0.1 divided by 5. And so we'll have the rate of diffusion of G to be equal to 0.02 cm cube per seconds. Okay, 0.02 cm cube per seconds. Okay, now we are going to try to find how long it will take. And that's what the question is asking. We are trying to find how long it will take. So let's do that. We know that for every 1 seconds we have 0.02 cm cube. So how long x will this take for 600 cm cube to diffuse? So when we cross multiply, we'll have x to be equal to 600 divided by 0.02, and this will be equal to 30,000 seconds. 30,000 seconds. So we can convert this to hours and find out how long it will take for this gas to diffuse. So, well, if you like this video, don't forget to click the like button and also subscribe and share with your friends. Thank you.